Alright, just a quick video here because I have not been working on this a whole lot this weekend. I did get all the parts soldered on, and seems like it works. I accidentally put this U11 on backwards the first time, and when I plugged it in, it basically burned up, so I had to replace that little section. But the 18S and 12S connectors work. They're kind of difficult to populate. I ended up making a couple of population pieces out of another PCB, but again, this connector we've not been able to find, and so it's literally just single pin things soldered on, and so it doesn't look great, but it does work. Every pin is connected at the end of the day. It just takes a few minutes to solder on each connector, so pretty annoying. It's looking like long term it's not going to be a huge deal because the large cache of these 18S modules are going to not have connectors anyway, so we're going to have to basically design a new connector onto this PCB. And so what I will probably do is, of course, we're going to ship this PCB with the connector as it is now, but I think for the longer term, we'll end up designing on our own connector, and then we'll have a connector made up for those 18S packs. But anywho, I've got all the parts soldered on. I haven't even tried to talk to it yet. I'm going to turn this light down so you can see. Because ISO-SPI is an isolated bus, if you pulse the bus, it will wake up, and I've got LEDs on each one. So the reason I turn that light off is so I can basically come from here to this positive tab, make sure we're here, and this is a 10 mega ohm resistor, and when I touch this, it's going to turn all 5 of the LEDs on. So that tells us that the DRV8018s are all working, and yeah, so that's as far as I've tested that so far. Basically, those are watchdog LEDs. They basically turn on every time they get a command. They'll stay on for, I think, 2 or 3 seconds. So nothing too exciting, but again, the board is fully populated now. Plugging it in was, you definitely need to be careful, and there's definitely a process that I kind of worked out to do so, and we'll get into that at the appropriate time, but it is possible to plug them in safely. But yeah, it's definitely got to be careful. So for example, from 1 minus here to 35 plus, I mean, that's 120 volts or whatever. And so you wouldn't want to touch across that. That would electrocute you right there. And the gradient basically is that, the further you come this direction, the higher the voltage is. But that is definitely energized at this point. Again, cutting the switch off here for the IMA cutoff does not open this. The reason we had to do it that way is that you can't break these 12S modules. You can't break them in the middle, or it will burn out this IC. There's a note here that basically talks about why you can't do that. So anyway, turning that switch off does not break the pack here. It does break it to the one in this bay. So this is a fully isolated bay here. This is actually the least dangerous of the danger elements here. It's certainly this left half of the board that you don't want to touch. And so as I've been thinking about it here, I'm thinking I'm going to probably look at getting a full wraparound, a folded like acrylic cover for this. Haven't really done any of the work for that, but we do have a supplier in Texas that does all of our folded and formed plastic. So it would basically be something. I'm grabbing a piece of this plastic right now, if I can. Anyway, story for another day. That's it. It is connected. It's powered. And gosh, that was a lot of work soldering all of these pieces on by hand. I probably should have just started with a new PCB, but here it is now. So, fun times.